Could you find the entire universe with all its history and complexity just by looking into a simple glass of wine? Well, the brilliant physicist Richard Feynman certainly thought so. So let's dive into this beautiful idea and see just how everything connects. You see, Feynman's whole point was this. We humans love to divide science into these neat little departments, right? Physics, chemistry, biology. We do it for our own convenience. But nature itself, it doesn't know anything about our labels. It's all just one big, interconnected system, and physics is the fundamental set of rules that governs the whole show. So we're going to go on a little journey here, and we're going to use this glass of wine as our lens to see that hidden unity.
And Feynman himself said it best. A poet once said, "The whole universe is in a glass of wine." It is true that if we look at a glass of wine closely enough, we see the entire universe. This quote is basically our map for this explainer. So, let's start looking closely.
Our first stop on this tour? It's chemistry. How do all the atoms in the wine swirl around and combine? Well, you might have guessed it. The rules for that game are written by physics. Feynman had this incredible analogy for it. He said chemistry is like a game of chess. Thanks to quantum mechanics, we know the rules of the game, how the atomic pieces are allowed to move. That's kind of like inorganic chemistry. But trying to predict the outcome of this incredibly complex game of life, what we call organic chemistry, well, that is a whole different ballgame. So, think about it. You've got trillions upon trillions of atoms jiggling around in that wine. How on earth do you handle that? I mean, you can't possibly track every single one. Well, the amazing insight is that you don't have to. Physics gives us this amazing tool called statistical mechanics. It just uses statistics to predict what the whole crowd of atoms is going to do. And that becomes the foundation for understanding things like heat and all those chemical reactions. Okay, so let's move on and see how this builds, from those basic chemical pieces to the absolutely incredible machinery they create, life itself. Just think about the sensation of tasting that wine. How does that message travel from your tongue to your brain? Well, the physics of it is just beautiful. A nerve impulse is like a wave of falling dominoes. An electrical charge gets triggered, and this wave of change just rushes down the nerve fiber. It's a beautiful, purely physical process. But for life to even happen, chemical reactions need to occur pretty easily. The problem is, most reactions have this huge energy barrier, like a mountain they have to climb over. So what's biology's solution? Enzymes. These things are basically tiny molecular machines that bore a tunnel straight through that mountain, letting life's chemistry happen super efficiently without needing, a blowtorch. And how does a cell actually manage its energy? Take a look at the Krebs cycle. You can think of it like a little gearbox. The transformation from GDP to GTP is like winding up a spring, storing energy. And then that stored energy can be released to power other things, like making a muscle contract. So how in the world did scientists figure out these fantastically complex pathways? Well, physicists gave biologists this absolutely crucial tool, isotopes. By tagging atoms with different weights, it's like putting a little glowing green mark on them. Scientists could actually trace their exact journey through the incredible assembly lines of life. And of course, at the very heart of it all is the blueprint itself, DNA. And its physical structure is the whole secret to how it works. It's this paired chain, right? And the links only fit together in specific complementary pairs. So when it splits down the middle, each half automatically builds its perfect counterpart. It's just this elegant physical mechanism for perfectly copying the instructions for life. All right, now we're going to zoom way, way out. From the tiny atoms in the wine all the way to the place where those very atoms were forged, inside the cosmic furnaces we call stars. It's mind-blowing. By using a spectroscope to analyze the light from distant stars, we can actually see the unique frequencies, the tunes, that the atoms inside them are playing. And the discovery? They're made of the exact same stuff as us. The iron, the carbon, every element in that glass of wine, and in your body, was cooked up inside a star and then spat out across the universe. But for all that we know, science is really defined by its frontiers, by what we don't know. So what are some of the great unsolved mysteries that are still out there? Well, here's a great irony for you. We understand the inside of a distant star millions of light years away with incredible precision. But the swirling, circulating currents deep inside our own Earth, the very things that drive earthquakes and volcanoes, they are a profound mystery. We just can't solve the math yet. Now let's get even more personal. As you're listening to this, you're having a thought. What is that thought physically? What is its manifestation in the atoms and electrons of your brain?
Here's the fundamental mystery. Whenever we learn something, whenever a memory is formed, the atomic structure of our brain has to change. It must. But we have absolutely no idea what that change looks like, or even where in the brain we should be looking for it. This is really the ultimate frontier. And you know what? Even physics, our foundational science, has its own roadblocks. It doesn't have what you might call a historical question. It can't tell us why its laws are the way they are. And it still can't mathematically solve the chaotic turbulence of what Feynman called wet water, just water flowing through a pipe. It's a problem that's over 100 years old and it's still unsolved.
Okay, so let's bring it all back home. We've kind of taken this universe apart, piece by piece. Now it's time to put it all back together again, right inside that glass. This really brings the whole idea together beautifully. The twisting liquid, that's physics. The glass, which is just a distillation of the Earth's rocks, that's geology. The ferments and enzymes, that's biology. And the elements themselves, that's pure astronomy. It's all there, all interconnected in one single glass. And I really have to leave you with Feynman's own words because he just says it perfectly. If our small minds, for some convenience, divide this glass of wine, this universe, into parts, remember that nature does not know it. Let it give us one more final pleasure. Drink it and forget it all. What an incredible way to see the world.